Welcome. What is Mars 2020? Mars 2020 is a Mars rover mission by NASA's Mars exploration program with a planned launch on July 17, 2020, and touchdown in Jezero crater on Mars on February 18, 2021. It will investigate an astrobiologically relevant ancient environment on Mars and investigate its surface geological processes and history, including the assessment of its past habitability, the possibility of past life on Mars, and the potential for preservation of biosignatures within accessible geological materials. It will cache sample containers along its route for a potential future Mars sample return mission. Mars 2020 rover tests on Earth. The currently unnamed Mars 2020 mission was announced by NASA on December 4, 2012 at the fall meeting of the American Geophysical Union in San Francisco. The rover's design is derived from the Curiosity rover and will use many components already fabricated and tested, new scientific instruments and a core drill. It will also carry a helicopter drone. The Mars 2020 rover will explore a site likely to have been habitable. It will seek signs of past life, set aside a returnable cache with the most compelling rock core and soil samples, and demonstrate technology needed for the future human and robotic exploration of Mars. A key mission requirement is that it must help prepare NASA for its long-term Mars sample return mission and crewed mission efforts. The rover will make measurements and technology demonstrations to help designers of a future human expedition understand any hazards posed by Martian dust, and will test technology to produce a small amount of pure oxygen from Martian atmospheric carbon dioxide. Improved precision landing technology that enhances the scientific value of robotic missions also will be critical for eventual human exploration on the surface. The mission will also attempt to identify subsurface water, improve landing techniques, and characterize weather, dust, and other potential environmental conditions that could affect future astronauts living and working on Mars. NASA announced in June 2019 that a student naming contest for the rover will be held in the fall of 2019. Voting on 9 finalist names was held in January 2020, and the winning name will be announced in early March 2020. Mars 2020 is a NASA rover that will launch to Mars in July or August 2020 and arrive on February 18, 2021. The rover will search for signs of past and present life, while collecting soil and rock samples for future return to Earth. NASA's yet-to-be-named Mars 2020 mission will send an advanced roving laboratory to Jezero crater on Mars, the site of an ancient lake and river delta. There, the rover will study rocks that formed in habitable environments and may preserve signs of past microbial life. Throughout the mission, it will collect soil and rock samples and leave them on the surface for collection by a future Earth return mission. Only when the samples are returned to Earth will scientists be able to determine whether definitive signs of ancient life are present. Mars 2020 is similar in structure and appearance to NASA's Curiosity rover. The components it will use to land on Mars are nearly identical to those used for Curiosity, but there are some upgrades, and the science instruments are entirely different. Mars 2020 and more landing sites. The Mars 2020 mission science goals fall into 4 categories: geology, astrobiology, sample caching, and preparation for human exploration of Mars. 1. Geology. Characterize the processes that formed and modified the geologic record within a field exploration area on Mars selected for evidence of an astrobiologically relevant ancient environment and geologic diversity. 2. Astrobiology. Perform the following astrobiologically relevant investigations on the geologic materials at the landing site. Determine the habitability of an ancient environment. For ancient environments interpreted to have been habitable, search for materials with high biosignature preservation potential. Search for potential evidence of past life using the observations regarding habitability and preservation as a guide. 3. Sample caching. Assemble rigorously documented and returnable, cached samples for possible future return to Earth. Obtain samples that are scientifically selected, for which the field context is documented, that contain the most promising samples identified in the astrobiology objectives and that represent the geologic diversity of the field site. Ensure compliance with future needs in the areas of planetary protection and engineering so that the cached samples could be returned in the future if NASA chooses to do so. 4. Preparation for humans. Contribute to the preparation for human exploration of Mars by making significant progress towards filling at least one major strategic knowledge gap. The highest priority SKG measurements that are synergistic with Mars 2020 science objectives and compatible with the mission concept are demonstration of in-situ resource utilization technologies to enable propellant and consumable oxygen production from the Martian atmosphere for future exploration missions. Characterization of atmospheric dust size and morphology to understand its effects on the operation of surface systems and human health. Surface weather measurements to validate global atmospheric models. Gathering data to inform future landings with a set of engineering sensors embedded in the Mars 2020 heat shield and back shell, including sensors for aerothermal conditions, thermal protection system performance, and aerodynamic performance of the Mars 2020 entry vehicle during its entry and descent to the Mars surface. Mars 2020 mission timeline, mass now 1,050 kilograms. Cost and key personnel. Mars 2020's estimated cost through the Prime mission is $2.46 billion. Thank you for watching this video. Goodbye.